All right, this is week 3, Math 208, section 306. All right, so what we're being asked to do is we are supposed to find the slope-intercept form. So you remember what the slope-intercept form. The slope-intercept form is y is equal to mx plus b. So that's the slope-intercept form that we're supposed to find. However, the piece of information that we're given is the slope, which is 3, and the fact that it passes through a point, which is -6, 8. All right, so I'm going to show you two ways to get the answer. The first way is the slow way that I don't want you to use, but it's going to help you understand what's going on. And then the second way is the fast way, but it's more algebraic, so it's easier to like a what? What is that talking about? So the idea is we're going to start at -6, 8 on our line. So we know that it starts at -6, 8. So I'm going to put a dot at -6, 8, which is right here. Okay. Now we know that the slope is 3 because it says so. So what does that mean? Well, that means we're going to go up 3 over 3, up 3 over 1, up 3 over 1. So if we go up 3 over 1, that puts the dot there. All right, now we've already kind of run out of room, right? So the idea is we know it's going to keep going this way, but we don't exactly know where it's going to intercept our y-axis, right? I mean, we don't know exactly. We know, boom, it's going to crash here, but what is that? Because you can't really draw everything perfectly. So what we're going to do instead, that's the slow way. So now what we're going to do is instead we're going to use what's called the point slope formula. All right, and so what we're going to do is, and you have to memorize this or write it down in your notes. So it's going to be y minus y1 equals m times x minus x1. So this equation you have to write down, and because you've got to have that at your disposal, especially when you take the final. So the idea is, so we see this -6, 8. So that is your point. And so I'm going to zoom in, and so the -6 is your x1, and the 8, is your y1. All right. So there is your x1 and y1. And then, of course, you remember that 3 is our slope. So that's your m. All right. And so now that we know what m and x1 and y1 are, now we're able to insert that into our equation right here. So y stays the same. So y stays the same minus, but now y1 is right here. It's 8 for this problem equals. Now m we're going to replace with 3, and then parenthesis, quantity, and then the x stays the same. Now here it gets a little tricky. So it's going to be minus, but then it says x1, and x1 is a negative, so it's going to be minus a -6. All right, so I'm going to quickly help you with that one, which is, okay, the y minus 8 stays the same, and then 3 stays the same. And then, so what's this minus a -6? Well, minus a -6, that's the same thing as just saying x plus 6. All right, so there's your your formula so far. But remember, we want to take this formula and make it look like the slope-intercept, because that's the directions. It says get it in the slope-intercept form. So we just have to do some manipulation. So we're going to start with y minus 8 equals, and now we're going to use the distributive property, and that's going to give us 3x plus 18. And then we want to get, because notice up here, we want to get y all by itself. So we need to get rid of this -8, means we're going to add 8 to both sides. And so adding 8 makes that a 0. So you end up with y equals, and then this becomes 3x plus 26. And that is your slope-intercept form. So what does that mean? Well, that means when we were going up this line, that this line point right here was finally going to cross at 0, 26. So here's 0 down here, and then it was going to go up 2, 4, 6, 8, 10, blah, 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 and it was going to keep going until we finally crashed at 26. So no wonder we couldn't use this slow method. And that is your technique. So the important thing that I want you to know is, one, is you have to memorize or write down this thing. It's called the point slope formula, and it's called the point slope formula because you know a point, x1, y1, and you know the slope. So that's called the point slope formula. And then what you did is you filled in your values, and eventually you worked your algebra until you ended up with your slope-intercept formula. And it's called the slope-intercept formula because you have your slope and your intercept, your y-intercept. So another problem, same. So we know that we want to find the slope-intercept form, and we've been given the slope and a point. And since we've been given the slope and a point, means we are going to use the slope, point slope formula. And so that's going to be y minus y1 is equal to m times x minus x1. All right, now remember, if 9, negative 9 is one of your points, because it says so right there, that means the 9 is your x1, and the negative 9 is your y2. I'm sorry, y1. Gee whiz. So it's always x1, y1. Always, always. x1 comes first, y1 always comes second. Always, 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 always. And then we know the slope is right over here, 5/6. All right, so slope is equal to 5/6. All right, so there's our two pieces of information, and we're going to substitute it into our equation. I'm going to move over a little bit. So you end up with y minus negative 9 equals 5/6 times x minus 9. So the big thing is to be careful. It's y1 was a negative 9, so you have to do a minus negative 9. And so to simplify that a little bit, that becomes y plus 9 equals, and then I'm going to use the distributive property here also. So that gives us 5/6 x minus 45/6. And that 45/6 is because 5 times 9 is 45/6. All right, so now what we have to do is, remember, we're trying to get our equation to be y is equal to mx plus b. So since we want to get our equation to be y is equal to mx plus b, that means we want y to be all by itself. So we need to get rid of that adding by 9. So what are we going to do to get rid of that adding by 9? Well, we're going to subtract by 9. All right, and so I'm going to scooch over a little bit. So that gives us y equals 5/6 x minus 45/6 minus 9. All right, now I'm not simplifying this yet because I'm going to show it to you in 2 steps. And the way we can combine these like terms is we need to get 9 to be a fraction with 6 as the denominator. So that 9 is equal to 54/6. All right, and how did I get that? Well, because 54 divided by 6 is 9. So I just changed the 9 to be 54 sixths. So now we've got y equals 5/6 x, nothing to do there. But now we've got this part right here. So you've got negative 45 sixths minus 54 sixths. So I'm going to go over here on scratch paper for a second, and let's talk about that. All right, and I'm going to ignore the sixths for a second. Basically, we have negative 45 minus 54. And you got to remember, the way you subtract negative numbers is that first number stays the same, the minus sign turns to a plus, and the second number, which used to be 54, becomes a negative 54. So really, we're going to add and have it be a negative. So it ends up being negative 99. So that's our scratch work. So I'm going to go back to our equation over here. So this ends up being negative 99 sixths. Now technically we're done, all right, but we can simplify that 99 sixths. And so the 5/6 x stays the same, minus. Now both of these numbers are divisible by 3. So we're going to divide and reduce that fraction. We end up with 33 over 2. And there is your equation. So, oh my goodness, that's a crazy one. So you end up with y is equal to 5/6 x minus 33 over 2. And there is no need for you to simplify this to be a mixed number. You can leave it as an improper fraction. So we got more of the same. We're going to try and create the slope-intercept formula, slope-intercept formula. But this time we're only given 2 points. We aren't given the slope. Well, the way we're going to find the slope is we're going to graph those points, and then we're going to calculate the slope. So first off, where is 6, negative 5? Well, 6, negative 5 would be right here. There's that point, 6, negative 5. And then 5, negative 4. 5, negative 4 would be right here. And so what is our slope? Well, we know our slope is when you are going from left to right. And I'm going to do green here, and I'm going to zoom in. And so our slope going from left to right is rise over run. So it goes down 1 and over 1. So we know that our slope is negative 1 over 1. Negative 1 because it goes down 1 and then over 1. So our slope ends up being negative 1 because this fraction simplifies to negative 1. So now we know what our slope is. Our slope is negative 1. And so now we have 2 different points. It doesn't matter which point we use, but we now have our slope, we now have a point, and so we're now able to use that point slope formula, which is y minus y1 equals m times x minus x1. And it doesn't matter which point we use, so I like to use the one that has the smaller numbers. So 5 comma negative 4, that's your x1 and y1, and we have our slope right here. So let's get going, and I'm going to scooch that over a little bit. And so we have y minus negative 4 equals negative 1 times x minus 5. Where did all that come from? Well, what's y1? y1 is negative 4, so it becomes y minus negative 4 equals, what's m? m is negative 1, so we're going to replace the m with negative 1 times the quantity x, because that stays the same, minus, now x1 is positive 5, so it's x minus 5. So there you go. And now we just have to do our algebra. So this becomes y plus 4 equals, and now we're going to use the distributive property here. So negative 1 times x becomes negative 1x, and then think about this as negative 1 times negative 5, so that becomes positive 5. All right. And remember, we want to get the y all by itself, so we're going to subtract both sides by 4. So that becomes 0. And you end up with y equals, and then it becomes negative 1x plus 1, and there is your slope-intercept formula. So what does that mean? Our slope-intercept formula means the slope is negative 1, means down 1 over 1, down 1 over 1, and our y-intercept is 1. And sure enough, if you look at this, that's exactly what our line is. It's right here, and our intercept, I got lucky, I drew it accurately. Our intercept is 1, so our equation here is negative 1x plus 1. So again, we're going to be trying to find that y equals mx plus b formula for this line, and we're given two pieces of information. So we're given that the x-intercept is 3, meaning it goes right there, and that the y-intercept is 1/3. Oh my goodness. Meaning, I'm going to zoom in. So our x-intercept is 3, goes right there, and then our y-intercept being 1/3 means it's kind of right here. So our point there is 0, 1/3. All right, and so, whoops, right there. So this thing right here is 1/3 above the x-axis, right? 1/3. And so if we wanted to find this, the slope, remember the slope is and I want blue here. It's the rise over the run for this line, all right? And so what we need to do is, I'm going to zoom in a little bit here, and so remember the rise. Well, what's the rise? It's right here, and it happens to be a negative rise. It's a negative 1/3. And how did I get that? Because we were told that this point is 1/3 above the 0. And then the run, that's easy. That's 3. So the rise over the run is, so slope is rise, which is negative 1/3 over 3. That's the run. And so we need to simplify that. So the way we simplify this is we think about it as negative 1/3 divided by 3, because that's what this is, negative 1/3 divided by 3. And so that becomes, these are fractions, so you got to know your fractions, which becomes times by 1/3, because the first fraction stays the same, the division symbol turns to a multiplication symbol, and the second number becomes its reciprocal. It goes on its head. It flips over on top of its head. And so this right here equals negative 1/9. So there equals negative 1/9. So our slope, oops, right there, our slope is negative 1/9. So that's our slope. So I'm going to zoom out of here. So we now have 2 points. We have our information. We have a point, which is our x-intercept is 3, 0. All right, and because I'm choosing this point right here. So there's our point, and then our slope is negative 1/9. So there's the two pieces of information we need, the point and the slope. And we are now officially ready to do the slope, the point slope formula, which is y minus y1 equals m times x minus x1. And remember, here's your x1, y1, and of course here is your slope. So now we're ready to start plugging it in. So this becomes y minus 0 equals negative 1/9 times x minus 3. All right, and now when we start doing the math, this is easy. That just becomes y. So already the y is all by itself, which is exactly our goal. So now we just have to use the distributive property here. And the distributive property becomes negative 1/9 x. And then I want you to think of this as negative 1/9 times negative 3. So that becomes positive 3/9. Now that is the answer, but my math lab would mark you wrong because the y-intercept here can be simplified or reduced. So that becomes y equals negative 1/9 x plus 1/3. And how did I get that 1/3? Because I divided both the numerator by 3 and the denominator by 3. And so that gives us our slope-intercept format, which is exactly what we wanted. So this is more of the same, but they're giving us slightly different information. Again, we're still going to be looking for that slope-intercept form. We're going to be writing it. We're going to use the point slope formula to get there. And the two pieces of information, okay, well, they're giving us a point. Yay, we know we need a point. But it doesn't look like they've given us the slope. And it turns out they have. Because when it says it's parallel to this line, now this line right here has a slope, and the slope is 3. All right, and so when a line is parallel to another line, it means those two lines have the same slope. And so, for example, like if we were to say, let's move this over here. So let's graph this. Let's graph the 3x plus 5. Well, graphing 3x plus 5 is really easy because when it's plus 5, that means we know it's going to cross the y-intercept right there. And because we know the slope is 3, it means the slope is going to be up 3 over 1, up 3 over 1, up 3 over 1. And so up 3 over 1 goes right here. Up 3 over 1 goes right here. And if I wanted to backtrack, I can go right here and right here. So we see that our line, this line is the y equals 3x plus 5. All right. So now the line we're looking for is going to go through this point. So 4, negative 6. So 4, negative 6 is right here. And we know that the line that we're trying to draw is going to have that exact same slope. So the best I can, I don't know how I'm going to do this. Let's see. So I know what I'll do. I'll copy. All right, and then I'll move it. All right. So we know that the line that we're looking for is going to have the exact same slope as the blue line, which means we know this slope has to be 3 because they have the same slope. All right, so now we have the two pieces of information we need. The two pieces of information we need is the slope, which is 3, and then we need a point. And the point is 4, negative 6. So that's our x1, y1. And now that we have the two pieces of information, we're going to plug that into that classic y minus y1 equals m times x minus x1. And so substituting, you get y minus negative 6 equals 3 times x minus 4. So you may need to pause to make sure you understand why I wrote it this way. And then so that becomes y plus 6 equals, now I'm going to use the distributive property here, so that becomes 3x minus 12. Now we want to get that y all by itself, so that becomes our 0. And so we get y equals, and then this becomes 3x minus 18. You may need to take a second to figure out how I got the negative 18 as opposed to a lot of students might think negative 6. And so that is our final answer. That is our slope-intercept format. And if you look at it, here's the line, and it says our y-intercept should be negative 18. And sure enough, if you look at this and kind of keep going down, it looks like if it were to continue, it'd crash down here, which is, you know, pretty low, right? So it looks like it's negative 18. So we know that our answer is at least a reasonable answer. All right, so again, we're supposed to find the slope-intercept form for this line. And we know that in order to do that, we need two pieces of information. We need a point. There's our point. But now we need a slope. But we don't have a slope. We're just told that the line is going to be perpendicular to this line. So our mystery line is going to be perpendicular. Now, what does that mean? Well, let's first draw this line, because it's the line we're looking for is going to be perpendicular to this guy. So let's draw this guy. And we know that because the plus 6, we know that it's going to cross at 6. And we see that our slope is down 1 over 5, down 1 over 5, down 1 over 5. So let's do that. Down 1, 2, 3, 4, 5 over 5, down 1, 1, 2, 3, 4, 5 over 5. And then we could backtrack it. So 1, 2, 3, 4, 5, up 1, 1, 2, 3, 4, 5, up 1. So we see the line is looking like this. Okay. Now this slope we know is negative 1/5, all right? And how do we know that? Because it says so right here. Okay, now, when a line is perpendicular to this guy, okay, so first off, let's put the point, 5, negative 4. So 5, negative 4 is going to go, let's see, 5, negative 4, right here. There's our 5, negative 4. So that's 5, negative 4. And so we know that when a line is perpendicular, okay, to this guy, what that means is it's going to cross and it's going to form, it's not going to be parallel, it's going to be the exact opposite of parallel, which is it crosses at a 90-degree angle. So it means it's going to just go, wah, bam, and it's going to cross at a perfect 90-degree angle. Now, here's the cool thing that we know about this line, is that if this line is negative 1/5, that means this slope, okay, now catch it, this is going to be crazy, is going to be the opposite of the reciprocal. So this is negative, which means our new slope is going to be positive, so that's the opposite part. And the reciprocal means instead of 1 over 5, it becomes 5 over 1. So there is our slope of this new line that we are looking for. And remember, positive 5 over 1, well, heck, that's the same thing as 5. So our slope is 5. So what are the two pieces of information that we have? The two pieces of information that we have, slope is equal to 5, and one of the points, one of the points is 5, negative 4. All right, so there is the two pieces of information we need, and we are now officially ready to use that point slope format. Y minus y1 equals m times x minus x1. And so now we're ready to start substituting the values. So you get y minus negative 4 equals 5 times x minus 5. So you get y plus 4 equals 5x minus 25. Now we're going to subtract 4 from both sides. So that goes away. You end up with y equals 5x minus 29, and there is our formula. So if you think about it, this is saying, first off, it's got to be going up 5 over 1, up 5 over 1, up 5 over 1. That's what this means, and that's our line. Up 5 over 1, up 5 over 1. And then it says it's going to cross the y-axis at negative 29, and sure enough, if you could see that if we were going to continue this line, it would be way down here at negative 29. So that tells us that our answer, is probably pretty darn reasonable. So again, we're going to, we need to take this line and write it in the slope-intercept form. Okay, remembering that's y is equal to mx plus b. Okay, now the two pieces of information we need in order to do that is we need to know the slope and we need to know a point. So we need to know the slope and we need to know a point. Well, a point is easy because this table gives us 4 different points to choose from. So I'm going to choose 1, negative 5 because I like small numbers. All right, so there. Now, we need to figure out a slope. So the easy way to come up with a slope is to, plot 2 of these points and figure out the slope. And it doesn't matter which 2 points you use. So let's do 1, negative 5. And let's do, just to be different, 3, negative 9. So we'll do 3, negative 9. So let's see, where is 1, negative 5? Well, 1, negative 5 is going to go about here. There's our 1, negative 5. And then where is 3, negative 9? That's going to be way down here. So 3, negative 9 is going to go right here. All right, and so now we imagine our line is going like that. And remember, what is our slope? So the slope is your rise over run. And in this case, we have a negative rise. And so our negative rise is 1, 2, 3, 4. So our negative rise, because it's going down, is negative 4. And we could see that our run, that's pretty easy, is 2. So our slope for this line is negative 4 over 2. That's our rise over run. And then negative 4 over 2 reduces to negative 2. And that's because negative 4 divided by 2 is negative 2. So we now have our slope that we need. So the 2 pieces of information that we needed, slope is negative 2, and we needed a point, so I chose any one of these points, and I chose the one with the smallest numbers. So now we are ready to put that into y minus y1 equals m times x minus x1. And we are ready to start substituting. So you get y minus negative 5 equals negative 2 times x minus 1. And so that becomes y plus 5 equals, now we're going to do the distributive property. So that becomes negative 2x plus 2. Remember, because that's negative 2 times negative 1, so that's positive 2. And so now we're going to subtract both sides by 5. And so we end up, that becomes 0. So you get y is equal to negative 2x minus 3. And there is our formula. Now we want to look at that and say, well, does that make sense? And sure enough, if you look at this, wow, I drew it pretty accurately. We have a slope of negative 2, sure enough, goes down 2 over 1, down 2 over 1, down 2 over 1. And then our formula says the y-intercept should be negative 3. And if I zoom in, I can see that, oh yeah, it's pretty good. Right there is our y-intercept of negative 3. So that tells us our answer is probably correct. All right, now for this one, again, we are going to try and find that slope-intercept form. And so the things that we need is we need to know a point and we need to know the slope. So we have a point right here. In fact, they've given us 4 points. So I'm going to move that over here. And the 2 things we need is a point and we need a slope. All right. Now, any of these would count as a point, and it doesn't really matter which one we use. So let's do 12, negative 14. I don't know why I chose that one, but let's do that one. So 12, negative 14, that is our x1, y1. Now, the other thing we need is we need to know a slope. Right? Now, all of these numbers are too big. The negative numbers are too big. They go off of our screen, off of our little coordinate grid. So what I'm going to do is I'm going to just get rid of that stupid coordinate grid, and I'm going to draw a generic one, and then we are going to imagine any 2 of these points. So let's do, and it doesn't matter which 2 we choose. So let's do 6, negative 17. So where is 6, negative 17? Well, that means you're going to go here, and then you're going to go down. And so 6, negative 17 is right here. All right, so I'm going to zoom in. I'm going to write that down as 6, negative 17. All right, so just as an estimation. Now, let's do 8, negative 16. So where is 8, negative 16? Well, 8, negative 16 is going to be a little bit further, but not quite as deep. And so it's going to go right here. Note, and that, I'm going to zoom in. That's our 8, negative 16, and I will record that right here. 8, negative 16. So remember, so here's our line, and here's our line, and we have to figure out our rise and our run. All right, so now our rise. Well, down here we had to drop down to negative 17. Here we only dropped down to negative 16. So what did we do? We went up 1. So that's our rise. Now let's use logic and figure out our run. So here we had to go over 6. Over 6, and then here we had to go over 8. So the distance between these 2 is 2. So our slope, what's our slope? Remember, slope is rise over run. So in this case, our slope is 1/2, because we rise 1, run 2, rise 1, run 2, rise 1, 1, 2, run 2. So that is our slope. So now that we know our slope, we can write that in right here. And we are now officially ready and prepared to do our y minus y1 equals m times x minus x1. X minus x1, yeah. All right, so let's start substituting. So what do we get? We end up with y minus negative 14 equals 1/2 times x minus 12. And then this becomes y plus 14 equals 1/2 x. And then I'm going to do a little bit of scratch work over here. So we know that 1/2 times negative 12. So 1/2, let's just do times 12. That equals 12 over 2, which equals 6. So 1/2, positive 1/2 times negative 12 is going to give us negative 6. All right, and then we need to subtract 14 from both sides. And so that goes away. That's equal to 0. So we end up with y equals 1/2 x minus 20. And there is our slope-intercept format. And if you look at it, let's go back to our generic picture over here. You can see that it's going down, 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 down. And it looks like we're going to cross right here. And we can imagine that that is negative 20. And so that tells us our answer over here is probably pretty reasonable. And that wraps up this video.